Hello students, good afternoon everyone. This is your KP sir. Again came back to YouTube live classes again continuously for 1 week. I am going to continue it. So this time I came with engineering hydrology for AE or AEE. Complete picture of engineering hydrology for all state government competitive examinations. Complete picture of engineering hydrology for any state government competitive exam, UPPSC, TSPSC, APPSC, MPSC, whatever, for AE and AEE examination. What is required, the standard of AE and AEE, I am going to teach you. Complete subject, first topic to last topic, engineering hydrology I will deal. I will finish here in the YouTube only. Okay. So is it clear for everyone? Voice, video and audio, is everything clear? Shall we move on? Yes, Saran Kumar, classes will go on regular. Every day 4 p.m. to 5 p.m. every day I will take engineering hydrology for AE or AEE. Every day, daily 1 hour session I will take. Classes will go on regular only. Every day 1 hour I will take. Clear? 1 week continuous session. If not completed this month, next month again 1 week I will take. I will finish off engineering hydrology for AE and AEE. Mostly this week, this month 1 week, next month 1 week, total 14 hours. If required, will extend also. But I will take first topic to last topic of engineering hydrology in YouTube sessions only. Okay. So before going to start hydrology for AE or AEE, I am discussing about a full length course which is going to launch in the plus subscription course of Unacademy. Full length course on irrigation engineering which starts from August 12th, and full length course of engineering hydrology August 24th for GATE and ESC courses. Complete in-depth course, irrigation engineering 60 hours, engineering hydrology 60 hours for GATE and ESC. So you know about me, you use my code KPCIVIL, you will get 10% discount and other benefits also. So as early as possible you take plus subscription, because this much depth, 60 hours for irrigation, 60 hours for engineering hydrology, total 120 hours. No one will teach you total 120 hours of the subject of water resources. Okay, we'll start. We'll start with the subject now. So, water resources engineering. Water resources engineering. This water resources engineering classified into two branches: hydrology and irrigation. Water resources engineering classified into two branches: hydrology and irrigation. What the hydrology will deal with? Hydrology will deal with all natural aspects related with water, all natural phenomena. Hydrology deals with all natural aspects, natural phenomena related with water. What are all natural aspects related with water? Which include Very important. Yes, it is very important, Mr. D Singh, for APPSC, TSPSC also. The natural aspects include precipitation. Very good, Jagannath. Rainfall, precipitation, runoff, infiltration, precipitation, runoff, infiltration, evaporation, evapotranspiration. The natural aspects of hydrology. Hydrology deals with all natural phenomena related with water. Precipitation, runoff, infiltration, evaporation and evapotranspiration. I will ask you one question. Do you control any one of the aspects provided here? Will you control precipitation? Will you control runoff, infiltration, evaporation? All are natural phenomena, not at all under human control. All precipitation, runoff, infiltration, evapotranspiration and evaporation, all are natural phenomena under atmospheric control. Atmosphere forces, planetary forces, solar radiation, these will control, no human control. You understand? There is no human control. Human is not at all involved in this phenomena. Human not at all involved. Then what we are studying? How naturally the phenomena going to take place? How much amount of water coming into atmosphere to ground level? How much amount of water out of that coming? How much amount of water we are entrapping properly for human utilization? How much is absorbed by soil and undergoing infiltration? How much again escape into atmosphere through evaporation? Quantity measurement. So regarding this natural aspects, what we are knowing? We are going to know regarding these natural aspects. For AE and AEE, DSing for AE and AEE, this is a free course only, don't worry. Okay? And Arun Kumar, good one. You have to invest your time, that is very important. So, nice one, Arun Kumar. You have to, Mr. D Singh, you have to invest your time as per Arun Kumar said. So regarding these natural aspects, procedure of occurrence, how this natural aspects is going to occur, estimation, how much amount of these natural aspects, how much will provide, clear, how much water is provided through precipitation, how much absorbed by soil, again how much entrapped into atmosphere. That estimation means quantitative determination. We are discussing about quantitative aspects, quantitative determination regarding water. Then after quantitative aspects, what we are doing? We are going to plot various curves. Hydrograph, hyetograph, rainfall mass curve. So, analyzing quantitative aspects, analyzing that estimation of quantitative aspects, which are analyzed through it. Mr. KPCIVIL, why not Mr. Jaspal is not copied from me? Because I have started GATE coaching before Jaspal. You understand? Mr. KPCIVIL, I don't know who are you. If you have dare, you can write your name. Okay. I myself started GATE and ESC coaching before Jaspal. Okay. Why you thought of Mr. Jaspal has not copied me? You think about it, Mr. KPCIVIL. Okay. So hydrology deals with natural aspects of atmosphere, which include precipitation, runoff, infiltration, evaporation and evapotranspiration. These natural aspects deals with what? Procedure of how the natural aspects will occur, how to estimate these natural aspects, quantitative distribution, and finally we are analyzing, plotting the graphs. So quantitative analysis, finally graphs, very important aspect here. You are going to know about graph, hydrograph, hyetograph, hydrograph and hyetograph. You are going to study very detailed rainfall masker, hydrograph, hyetograph, rainfall masker we are going to study. So what you are knowing by this analysis, tell me. Finally, how much water is available for human use. By knowing how much water is available for human use under irrigation, so you can know quantity of water through hydrology. Very important link between hydrology and irrigation I am revealing here. Through hydrology, you are going to know how much quantity of water effectively available for human consumption. After knowing how much quantity of water effectively available for human consumption, now you are designing and constructing, design and construction of structures. Design and construction of, will the structures are natural or artificial? Tell me, will the structures are natural or artificial? Okay, Mr. KPCIVIL, Mr. Arun Kumar comment, you said like that. Okay. So design and construction of, yes, artificial structures, very good. Design and construction of artificial structures. For what purpose? Yes, man-made structures. Very good, Keshav. Shrikant, artificial. Sandeep, artificial. Jagannath, Keshav, very good. So design and construction of structures, artificial structures. For what purpose? So we have some quantity of water from hydrology. Na? From rainfall, whatever remaining stored quantity, some quantity provided through hydrological aspects. We have measured, estimated, analyzed. Finally, for example, per year you are having some quantity of water like 1000 million liter. What you can do? So that 1000 million liters of water can be stored first. Then from storage structure it should be diverted, structures for storage, diversion, conveyance, and finally discharge at the required region. You understand the point? From hydrological aspect, whatever quantity of water available from the nature, we estimated. Q, discharge is estimated. Using the discharge, we go for a design procedure. We go for design and construction of structures to store, to divert, to transport the water. So the design and construction of artificial structures studied under irrigation engineering. Very important. We are not going to name just irrigation. This is irrigation engineering. Yeah, Ruchi Sinha, it may be for irrigation purposes. It may be for irrigation purposes, it may be for hydroelectric power plant, it may be for domestic water supply project, whatever different needs. But finally, what is irrigation engineering deals with? Will it deal with natural or artificial? All artificial aspects related with water. You got the point? All artificial aspects related with water. All artificial aspects related with water, that was dealt with irrigation engineering. So all natural aspects you are studying in hydrology, all artificial aspects you are studying in irrigation engineering. You got complete relation between hydrology and irrigation. through natural phenomena of rainfall, runoff, infiltration, evapotranspiration, estimation, analysis and all calculations done. How much water available finally? Depending upon that quantity of water, what is the capacity of reservoir required? What is the foundation needed for a dam? What diversion structure required? What is the depth of canal needed for conveyance? Depending upon quantity only. Na? Without knowing quantity, can you design a reservoir? Can you design a dam? Can you design a barrage? Can you design a conveyance structure? Canal? Channel? No, no. From where you are getting that quantity? That quantity discharge obtained from hydrology. So that is the clear link between hydrology and irrigation. Hydrology clearly deals with only natural phenomena, not human involved. Irrigation completely human design and construction, man-made construction. Okay, we'll move on now. Clear for everyone? Shall we move on now? So when you come for weightage of the subject, weightage of the subject we are discussing. So this is hydrology only, so I am talking about hydrology regarding weightage. You have 4 to 5 questions. You have 4 to 5 questions in AE or AEE examination. Very small subject. This is important, you remember. Subject is very small. When compared with irrigation, hydrology is very small subject. Less number of topics. But equal weightage like irrigation, you have for sure 4 to 5 questions for AE or AEE. And you are going to get 5 to 6 marks for gate examination. 5 to 6 marks in gate examination. Same manner, you have 5 to 6 questions in other SSC, JE and other competitive examinations. Other exams, you have 5 to 6 questions. So minimum 4 questions you can expect in any kind of exam. 4 questions in any kind of exam you are going to expect from hydrology. If you focus 15-20 hours, subject is completed. Very important thing I am going to say. 15-20 hours subject completed, you are getting 4 questions, you are writing 4 questions means your time is effectively invested here. So easily you are going to solve all simple theoretical questions only from hydrology. Okay, we'll move on. So this is a definition for hydrology. The branch of science, it is not branch of engineering. Clearly I have written here, you understand it. Hydrology is a branch of science. Hydrology is a branch of science which deals with 4 aspects: occurrence, circulation, movement and distribution. Occurrence, origin. What is origin of water? Occurrence, distribution will write down clearly. Occurrence, circulation, movement and distribution of water. So occurrence is origin. Origin of water. What is origin of water? Everyone knows it, na? Oh, Shrikant Behera. Origin of water is precipitation. Precipitation, rainfall, occurrence. Shrikant, ocean water is a huge quantity, but directly we can't use it. Na? That ocean water has undergone evaporation, converted into water vapor. That water vapor accumulated in atmosphere, then undergoes condensation and fall down as a fresh water through precipitation. So according to human being, according to hydrologist, origin or occurrence of water is through precipitation only. Shrikant, you got it? So occurrence is through precipitation. Then circulation. This water is circulating. So water is coming from where? Atmosphere. Water is coming from atmosphere. Then it is falling down either into ground level. What is ground level? Lithosphere. Or it may be falling down into a river, into a lake, into a water body or ocean. What we call it as any water body? Hydrosphere. Is it not? Water is circulating from atmosphere. It is falling down to ground level, lithosphere. It may be falling down into a water body. Water body is hydrosphere. Again, the same water undergoes. What it undergoes? Evaporation from hydrosphere to atmosphere. And again, same water from lithosphere to hydrosphere. It move on. So water is circulating between. So hydrosphere to atmosphere, what is happening? Evaporation is happening. Atmosphere to lithosphere and atmosphere to hydrosphere, what is happening? Rainfall is happening. Lithosphere to hydrosphere, what is happening? Subsurface runoff is happening. So by different phenomena, water is circulating between three zones of environment. Environment consists of three zones. You remember it. In several classes I taught to you. Atmosphere, hydrosphere and lithosphere, the three zones of environment. So the water which is originated through rainfall, precipitation, circulating between all the three zones of environment, atmosphere, hydrosphere and lithosphere, in different activity, through different activity. It may be from hydrosphere to atmosphere through evaporation, atmosphere to lithosphere to rainfall, lithosphere to hydrosphere through subsurface runoff. So Ritesh Burman, in plus course, I will teach irrigation, hydrology, already environmental engineering, open channel flow completed. I will teach irrigation, hydrology, construction materials, construction management. If time permits, one more subject I will teach before GATE exam. Okay? Done. We'll move on. Then movement of water. Movement of water. Where the water is moving? Water is going to move. Is water will, if you say river water, stream water, is it static? Is it static? It is not static. Na? Water is falling down into the river. At the falling down place only it is located. Continuously moving water body. So movement of water will give water, distribute water to various regions in the world, in the earth. Is it not? Continuous movement of water. Water is not static when it is coming into river or stream. So it travels a long journey, distribute water to villages, towns and cities. When it comes under this distribution, water is distributing on the surface, on the subsurface and also in water bodies. From one region to other region, one district to other district, one country to other country, distribution of water is going to take place. So that is what we have written here. The branch of science which deals with the occurrence, circulation, movement and distribution of water. Where? in environment. That is only shown na. Environment consists of three zones. That is only shown na. Atmosphere, hydrosphere, lithosphere. Where they are present? They are present above the ground means surface, below the ground means subsurface. Deepak Saini, movement when water is falling down onto ground level into a stream, the continuous movement by the river movement. River, for example, you take Godavari river. It starts from Maharashtra, Nasika of Maharashtra, and finally ends at Antarvedi. That is called movement of water. Distribution. Water may be present on the ground level. It may be present in the zone of subsoil, zone of saturation, water table. Throughout lithosphere it is distributed. Above ground level it is distributed. Below ground level, in the zone of subsoil, capillary water is there. In the groundwater table, water is there. Zone of saturation, water is there. That distribution above and below the ground level. Clearly written here in the definition. Above the ground surface, below the ground subsurface. That is called distribution. But water traveling from one district to other district, one state to other state, that is called movement. Got it, Deepak Saini? You understand it, Deepak Saini? Okay. So, all the four activity, occurrence, circulation, movement, distribution of water in environment, above the ground or below the ground, or even in atmosphere. Even it is distributing in atmosphere, in the form of evaporation happened. In the form of evaporation happened, even it is distributed into the atmosphere. Along with this, very important thing we are going to study. What is the very important thing? Depletion and replenishment. So water is getting depleted from the river, from the groundwater table, from the zone of saturation, fall down of water levels, and again when rainfall occur, they recharge. So every day you are using water from different sources. You are getting water from the river, you are getting water from the water table, you are getting water from the subsoil strata. Any day are you giving 1 liter of water return back to the river? Any day are you giving 1 liter of water to the zone of subsoil and water table? So if you have done recharge of your mobile, your balance is over. You are using every day. So immediately after balance over, you are recharging your mobile. So are you doing recharge of groundwater? You are consuming every day, you are consuming. Are you doing recharge of river water? Tell me. Tell me everyone. Are you doing recharge? No. So nature knows the selfish mentality of human. So what the nature made? Nature only created a phenomena. Replenishment of water resources of earth through evaporation and precipitation. Nature before human birth itself. You got it? Nature before human birth itself came to know the selfish mentality of a common human man, common human being. So because of that reason, nature itself provided solution for it. Recharge of water resources on earth. That recharge is called replenishment. Depletion by human usage, fall down, depleting, reducing. Then through evaporation, water is taken, fall down as precipitation. That precipitation will make replenishment of water resources on the earth. So we are going to study about it. The total phenomena. Why it is depleting, why it is recharging, what is the process, what are the forces involved. Everything we are going to study in hydrology. And finally, the effect of water on environment and life. Finally, the effect of water on environment and life. That is also studied. That is also comes under hydrology. Krishnakant Mishra, Mr. Robo. How are you, Mr. Robo? So hydrology finally concluded. I think you understand, everyone understand the definition. The branch of science which deals with the occurrence, circulation, movement, distribution of water in environment, above the ground, below the ground, or even in the atmosphere, along with the study of depletion and replenishment of water resources of earth and its effect on environment and life. That is called hydrology. We'll move on now. In a single picture, I will explain what we are going to do in hydrology. Okay. This is ground level and there is a catchment. This is a catchment. Now, this is a catchment. So, Mr. Krishnakant Mishra, you came here to know about time of plus course to the YouTube class. Just to know about time of plus course, you are entering into YouTube class. Krishnakant. Now, the clouds from the atmosphere, it is going to make release rainfall water. So what we consider this rainfall? Now this rainfall is an input. This is an input entering into catchment area. Rainfall is an input which is entering into catchment area. So this rainfall is falling down, move on, and entered into a structure which is called catchment. Will 100% of rainfall water input, total input, will be given as output from the catchment. For example, this is output from the catchment. And whatever output provided from the catchment, we call it as runoff. So you have given some input into catchment area as rainfall. You are taking out some output in the form of runoff through the catchment area. Well, input and output are exactly equal. Will input and output are exactly equal? Very good question, Venkatesh. Catchment is a structure which perform entrapment of rainfall water, store in it, and provide water after storage and provide water to required regions. In simple, catchment is a drainage area, watershed or ridge. Very important. In general, we call drainage any structure which entrap and store water is a drainage. In hydrology, the same according to Indian hydrologist, the structure which entrap water, which collect and store water. Simply, the structure which collect and store water, that is catchment. The same catchment in USA, we call it as the word watershed. Catchment, when you open foreign other textbooks, so USA, they call the catchment the structure which collect and store water, watershed. Same catchment you can apply the word in UK, ridge. Ridge. You got the clarity now? Mr. Venkatesh, you got the clarity now. In India, we are considering it as catchment. USA, that is watershed. UK, that is ridge. UK, that is ridge. Okay. Now, input is rainfall, output is runoff. Will both are equal? Now, whatever input rainfall we have provided by our Indian hydrologist or any hydrologist, he has differentiated rainfall into gain, losses. Gains and losses. Because input rainfall you have given into catchment. Na? That input rainfall entered into catchment after rainfall completed, some amount of water escape into atmosphere, loss. What is that loss? Evaporation. Yes, there is losses and gains, Venkatesh, correct? So escapes into atmosphere as evaporation. And water fall down onto ground level, absorbed by soil, subsoil, entrapped and given to water table. That is considered as infiltration. Infiltration. So we have different kinds of losses. What are those different kinds of losses? Here we conclude. These different kinds of losses we can conclude: evaporation, evapotranspiration, infiltration, etc. Then how many gains are there? Only one gain. That only one gain we consider it as runoff. So can you tell me, will actually evaporation is a loss? Will actually evaporation is a loss? If there is no evaporation, is there any precipitation? Will rainfall occur? Our hydrologist, numerically he is going to say it is a loss, because our hydrologist always want precipitation. He don't want water to last through evaporation. Or else he think that always ocean water only can undergo evaporation. River water never can undergo evaporation. Fresh water never can undergo evaporation. Always ocean water can undergo evaporation. Always river water must be stored and it should be gain only. But actually all natural phenomena are required. We need evaporation, we need evapotranspiration, we need infiltration. As per a hydrologist, during numerical calculation we consider it as losses. But without this phenomena, all are interdependent, there is no rainfall. You understand the point? Yes, Krishnakant, regarding syllabus change in GATE, I will take a special class on Tuesday or Wednesday. Don't worry, Krishnakant. You understand the point? According to hydrological calculations, only will consider it as a losses and gains. But according to atmosphere and nature, everything is important. Each and every hydrological phenomena is equally important. So what we have now? We are having an output runoff. We are having an output runoff. That runoff is equal to input rainfall minus losses. So into a system you are giving an input. Into a system you are giving an input rainfall. After completion of losses, it produces an output that is called losses. Clear? We'll move on now. Clear for everyone? Shall we move on now? Yes. Target 100 marks in GATE. I don't know who is this. Nice. You target 100 marks in GATE. Bring good name to Unacademy platform. Okay. Crack GATE with 100 out of 100. I don't know who are you. Okay. Yes, Jagannath, I thought of it only. He is only Krishna. So now, global water distribution. Global water distribution. The most repeated question in AE or AEE. what is the quantity of total water available in world? What is the quantity of total water available in world? Most repeated. So most repeated. Mr. Target 100 marks in GATE. Tell me the answer. Target 100 marks GATE. Tell me that answer. What is your answer? So that is 1380 million cubic kilometers. So this is very important question, repeated several times in AE and AEE examination. Okay. Total water available in the world. They will give in options, not exactly 1380. 1357.5 sometime, 1360 sometime, 1370 sometime. Nearby value you can choose. But this unit is very confusing. Million meter cube, million kilometer cube. 1380 into 10 power 6. 1380 into 10 power 6 kilometer cube. Total water available in the world 1380 into 10 power 6 kilometer cube. Then this water distributed in oceans. So after I have written the answer, you are answering means sure it is Krishna only. So in oceans, in this water, 97.2% available in oceans. 97.2% available in oceans. Then remaining is considered as freshwater resources. What is remaining? 2.8%. In this remaining 2.8% freshwater resources, glaciers are going to occupy 2.15%. Deep water bodies, very deep below in the bedrock, water which is available in the deep water zone. Those who have attended my environmental classes, they can understand. Zone of rock flowage. I clearly mentioned the earth strata below the ground level differentiated into zone of rock fracture, zone of rock flowage. So that water available in the zone of rock flowage, that comes under deep water, 0.32%. Srikanth Behra 1.33, it is not available. Out of 2.8, glaciers is 2.15, deep water bodies is 0.32. Remaining utilizable fresh water, because we are not going to utilize glacier water, we are not going to utilize deep water bodies. So remaining whatever available for human consumption, remaining utilizable fresh water, remaining utilizable fresh water. What is remaining? Very important, 0.33%. Remaining utilizable fresh water. Okay, Krishna, I understand. And also, if you put target 100 in GATE also, it is an insult. The people will feel like that. You also change the name. Very good, Rahul Gautam. So remaining utilizable fresh water, will consider it as 0.33% available for human consumption. So what is the value? In terms of million kilometer cube, what is the value? Fresh water available for humans. Fresh water available for human consumption. So 0.33 divided by 100 into total water. What is total water? 1380 million cubic kilometer. 1380 million cubic kilometer. So answer is rounded off to 4.5 million cubic kilometer. So out of 1380 million cubic kilometer total water, clear, out of 1380 million cubic kilometer total water, water available for human consumption 4.5 million cubic kilometers. Very important, these two values, 1380 and 4.5, these two values are very important. Previous questions, you remember it. Then I am writing some theoretical questions and standard values. Average annual rainfall in world. What is average annual rainfall in the world? Average annual rainfall of the world. That average annual rainfall of the world, 100 centimeter. 100 centimeter. The same question they have been asked according to Indian conditions. India. Keshav, that is India. Very good. 120. Jagannath, it is not 89. Srikanth, it is not 110. For the world, it is 100. For India, that is 120 centimeter. If you need accurate and you are going to express the answer in millimeter, you remember it as 1170 mm. This is accurate value. 117 centimeter, 1170 mm. Yes, correct, Venkatesh. In some books it was given 119, but latest value 1170 mm. Indian average annual rainfall. The same question is asked with respect to runoff. Average annual runoff. The value is 55 centimeter. Average annual runoff. The question is given regarding average annual runoff and it is said to be 55 centimeter. We'll move on now. Completed writing. Now, we have given India 120 centimeters is the average annual rainfall. Well, in each and every region in India, that average annual rainfall of 120 centimeters happened. Throughout the country, everywhere that same 120 centimeters happened? No. It varies. It varies between range of average annual rainfall, for different regions. Lowest value and highest value for different regions in India. Clear? Lowest value, it is 110 millimeter. Lowest value is 110 millimeter. 11,817 mm, highest value. This most clear, most dry region, 110 mm is in Western Rajasthan. Very important. Western Rajasthan, least wettest region. Lowest annual rainfall. Lowest annual rainfall happened in Western Rajasthan. And the highest annual rainfall. What is the highest annual rainfall? Where it is happening? Where it is happening? Mass syndrome. Clear? Rainfall is uneven with place and time. Very good, Sandeep Kumar. Rainfall is uneven with place and time. But highest value, lowest value we have for India. Lowest rainfall value in Western Rajasthan. Highest rainfall value in Mass syndrome. So regarding Mass syndrome, we have the question. Krishnakant, always you ask wrong question in a wrong platform. I told you already, I will take one session on changes in the gate. At that time, you ask everything. This is AEE Engineering Hydrology class. Mr. Krishnakant. Most wettest region. Most wettest region in the world. It may be in the world, and that world most wettest region is in India only. Clear? That world's most wettest region is in India only. Again, that is nothing but Mass syndrome. Clear? World's most wettest region, India's most wettest region, that is Mass syndrome only. And then it was followed by Cherrapunji of Meghalaya. Both are in Meghalaya only. Mass syndrome and Cherrapunji, both in Meghalaya only. Okay. So Cherrapunji is going to show 11,771 mm. Only 10 millimeter difference in rainfall between first place and second place. Like in GATE exam, between first place and second place, 1 mark difference only. Like that. 10 mm depth of rainfall is a small value. But due to that 10 mm depth of rainfall, Mass syndrome has taken first place, Cherrapunji has taken second place. So Mass syndrome is the world's wettest place number 1. Cherrapunji is the world's wettest place number 2. Both are in India only. Both are in India only. State with the highest rainfall in India. So as you are preparing for AE and AEE, this history is very important to you. Clear? This kind of questions only they will ask repeatedly. You must know this kind of questions. 10 mm. Yeah, correct. 10 centimeter. 10 centimeter. Correct. 10 centimeter. Jagannath. Correct. So you are preparing for AE, AEE examination. This kind of questions are very important. State with highest rainfall in India. The state with highest rainfall in India is Assam. State with highest rainfall in India is Assam. We'll move on now. hydrological cycle or water cycle. Hydrological cycle or water cycle. Who proposed water cycle? Hydrological cycle or water cycle is proposed by the scientist Vitruvius. Hydrological cycle or water cycle is proposed by the scientist Vitruvius. So from 7th standard, 8th standard, we are going to study about water cycle. This is a cyclic distribution of water between precipitation, three phases we can consider. Cyclic distribution of water between three phases or three hydrological events. Precipitation to runoff. Precipitation to runoff. And runoff water may undergo again. What the runoff water again will undergo? Either infiltration, water is getting absorbed, taken by the soil, or it may undergo again evaporation. Runoff water may undergo again evaporation. So evaporated water, will they be accumulated only in atmosphere or again fall down as precipitation? Again it is fall down as precipitation. Again infiltered water can undergo precipitation. Again infiltered water can undergo first evaporation and then precipitation. This cyclic distribution of water between precipitation, evaporation, runoff and infiltration, this is called water cycle. So if you study that simple precipitation, runoff, evaporation in 7th standard also we have studied, then we can understand as an engineer the rainfall precipitation. It may occur in the liquid state, what we consider it as rainfall. It may occur in the solid state, which we may call it as snowfall. Which we may call it as snowfall. And liquid state only, water droplets are performing both runoff as well as infiltration. Liquid state only, water droplets are only performing runoff, infiltration. But water escape into atmosphere from liquid state to what state? Vapor state. That means water is transforming between liquid to solid, solid to vapor, vapor to liquid, all the three states. So hydrological cycle, water cycle involves all three states of water, solid, liquid and vapor state. And also it involves all three zones of environment. What are all three zones of environment? Atmosphere, lithosphere, hydrosphere. Evaporation is happening. Evaporation is happening in atmosphere. Precipitation is happening, falling down, lithosphere. Runoff and infiltration is contributed, surface water, subsurface water, hydrosphere. So all three zones, na? Atmosphere perform evaporation, lithosphere is performing atmosphere to ground level, lithosphere, precipitation occurring. That liquid form of water goes to surface water, rivers, canals, lakes, catchment areas, or it may go into subsoil water. Again, that is subsurface hydrosphere. So it is circulating between three zones, no? Atmosphere, lithosphere and hydrosphere. What are forces involved here? This evaporation, again, evaporation is controlled by solar radiation. Is it not? Evaporation is controlled by solar radiation. Precipitation. Water is falling down from atmosphere to ground level under the influence of gravitational force, gravity. Water is moving on the runoff, on the ground level, moving on the runoff, absorbed by soil. Infiltration is going on where the earth's Coriolis forces are participating. Coriolis forces of earth are participating. So what we have studied in the 7th standard, 8th standard, hydrological cycle, precipitation, runoff, evaporation is different. As an engineering student, what you are studying is different. This is hydrological cycle. Water exists in 3 states: solid, liquid, vapor. Water exists in 4 phases. 4 phenomena: precipitation, runoff, infiltration, evaporation. Water circulate between 3 phases of environment: atmosphere, hydrosphere, lithosphere. 3 or 4 different forces: solar radiation, planetary forces, gravitational force, capillary, Coriolis forces. These are involved in the process. We are studying about phases of water, zones of atmosphere, forces involved, hydrological events. That complete picture is called water cycle. Coriolis force is different and gravitational force is different. In the soil voids, whatever force which can pull the water towards ground level, that gravitational force is called Coriolis force. Yes, KPCIVIL. Water is absorbed by soil going deep through capillary spaces. Those earth's attraction forces to take the water deep into the water bodies. That forces are called Coriolis forces. Those are called Coriolis forces. In surveying, you are going to study about it very well. Yes, due to rotation of Earth, correct Srikanth. Rotation of Earth is going to create this kind of Coriolis force. So I will write down definition for water cycle. The cyclic distribution of water, among hydrological phenomena, of precipitation, runoff, infiltration, and evaporation in either solid or liquid or vapor phases. Solid, liquid or vapor phases. And circulate among atmosphere, hydrosphere, and lithosphere. and all phases controlled by gravitational force, solar radiation, Coriolis, and planetary forces. Is called as water cycle. MVR sin theta. Amit Kumar, nice. So by this definition, I think you can understand the complete information about water cycle in a single statement. Cyclic distribution of water among hydrological phenomena of precipitation, runoff, infiltration and evaporation, either in solid, liquid or vapor states, and circulate among hydrosphere, atmosphere and lithosphere under the control of various forces like gravity, solar radiation, Coriolis and planetary forces, is called as water cycle. Clear? So for today I am going to close the session. So before that we'll solve some theoretical questions. Theoretical questions related to today's topic. So hydrology deals with. These lectures are only for AE, AEE, Keshav. By this, don't try to crack GATE and ESC. These lectures are for AE and AEE only. If you want to crack GATE and ESC, you join Plus Course Keshav. So hydrology deals with, very good, Jagannath, Venkat, Prakash, Srikant Behra. So Banu joined. Final session, question solving session, you can Banu. So hydrology deals with Jagannath, A is wrong, D. Hydrology deals with surface water and underground water. If you say hydrology deals with rainwater, will it deals only with precipitation? What about infiltrated water? What about evaporated water? What about runoff water? D. You understand? Rahul, Gautam and Jagannath. If you say rainwater, it is only related to precipitation. Remaining phenomena are not involved. So if you say surface water and underground water, everything. Rainfall is a surface water. Water available through runoff is a surface water. Water going through infiltration is a underground water. Water again escaping into atmosphere is a surface water. So answer is surface and underground water. Total quantity of water in the world is about. Total quantity of water in the world is about. So I told you only regarding confusion about this units and the word. We have given already actual value 1380 million cubic kilometer. So nearby value 1357.5. Actual value 1380 million cubic kilometer. So original value according to options 1357.5. So I am going to close the session for today. Okay, thank you one and all. A small announcement, there is a plus course, full length plus course on irrigation engineering which is going to start on August 12. Engineering hydrology. This is GATE ESC or any competitive exam, any exam. A single course for all kinds of exams I am teaching. Clear? A single course for all kinds of exams I am teaching. 60 hours irrigation engineering, 60 hours engineering hydrology. So take plus subscription using my code KPCIVIL. You will get 10% discount, free online test series, scanned copies of notes and materials, my support till you crack GATE and IS. I will guide you properly. Okay. Take plus subscription. If not, no issue. You follow free classes, but refer your friends to follow me on an academy. Take and refer them to take plus subscription. And you have any hats in the academy, you dedicate it to me. Okay. Tomorrow we will continue same hydrology AE AEE tomorrow at 4 p.m. Same session we have at 4 o'clock tomorrow. Okay. Thank you one and all. Bye bye all of you.